This one's starting with algebraically. Determine algebraically whether each pair are inverses of each other. So if we're doing part I have this equation. And if I want to find the inverse algebraically, I have to switch the x and the y, and then solve for y. So I'll start by switching the x and the y variables. And now I want to get the y by itself. So I'll add 6 to both sides. Divide both sides by 3, and I get x plus 6 all divided by 3. And the question says, determine algebraically if these are inverses. So I'm going to look at this one and this one. I just found the inverse. Are they the same? No, they're close. So one has a plus 6, one has a minus 6. They are not the same. So they are not inverses. So if we want to find something algebraically if they're inverses, we take one of them, find its actual inverse. If it matches up perfectly, then you know they're inverses. If they don't match up perfectly, then you know that they're not inverses. So this would be algebraically how to show if two things are inverses or not. Part B, it says verify the answer graphically. So we'll do that since we're working on this one right away. What I'm going to do graphically is I'm going to take both the equations and graph them in different colors. So the one equation was y equals 3x minus 6. I'll do that one in blue. And the other equation was y equals x minus 6 divided by 3. And x minus 6 divided by 3, when it's in that form, is a little bit harder to graph. You can change this. Okay, if I divide each thing by 3, this would be the same as 1/3 x, and 6 divided by 3 is minus 2. And what I'm trying to do here is change both of these, because they're both lines, into y equals mx plus b, so that we can graph it using our skills from grade 10 in graphing lines. How do we graph lines from grade 10? We start off with our y-intercept. So on the blue graph, our y-intercept is at 0 and negative 6. And in the blue graph, our slope is 3. So I can go up 3 over 1. Up 3 over 1. So I'd also have the point 1, negative 3, and 2, 0. And I can draw that line. Similarly, once I've changed the green one to y equals mx plus b, I would know that my y-intercept is at 0, negative 2. My slope being 1/3 would mean I could go up 1 over 3, up 1 over 3. So I'd have the point 6, 0, 3, negative 1. And I could draw that line. So part B says we want to verify what we found in part A. In part A, we found that they were not inverses. How could we say that based on these graphs?
I have a question.
Yes.
Do I have to include 3 points when I draw a line, or is 2
2
enough?
is enough. I did 3 in this case because I wanted to show some points in particular. But for a straight line, 2 is enough. Now, can we see that these are not inverses? Because if I draw y equals x in red as a dotted line, the blue one, if I flip the blue one over that, it does not match up with the green. So graphically, I can see they're not inverses because they're not a reflection over the line y equals x. Graphically, I can also see that they're not inverses because if I take 0, negative 6 and I switch the coordinates, I should have a point right there if I had the inverse, but I do not. Same thing on the green graph. I have 6 comma 0. But I do not have 0 comma 6. If these were inverses, then the coordinates should have gotten switched and they would match up perfectly. But we can see graphically that they do not. All right, we're going to go to part 2. For part 2, first of all, this is the first equation, and I want to point out that we have in this question listed with it a domain restriction. So that comma and then x is bigger than or equal to 0, this means that we have a domain restriction. If we think about negative x squared plus 3, so I'm going to have a little graph off to the side. Can you see that that's a parabola? Vertical reflection shifted up 3 units. This would be that parabola. And we are only looking at this half with the domain restriction. If I want to find the inverse, algebraically, I switch x and y. I want to get the y squared by itself, so first of all, I'll move the 3 over. Then multiply both sides by a negative. And now I can square root both sides. And I get plus or minus negative x plus 3. But since there was a domain restriction, we're only going to get one of those graphs. And we have to ask ourselves, is it going to be the positive one or is it going to be the negative one? And again, the way that we looked at this before, if we think about this graphically, on my original graph, on the yellow part, I have 0, comma 3. I also have 2, comma negative 1. Those are 2 points on that yellow half with the domain restriction. If I took those points and I switched my x and my y coordinates, and you see on the inverse, I would have 3, comma 0. I would also have negative 1, comma 2. So this would be my inverse graph. And I have to ask myself, does that inverse graph, has it had a vertical reflection or not? In this case, it's not going down. It has not had a vertical reflection. So my inverse will be the positive one. There's my equation. Does that equation match with what they said? 3 minus x. Ooh. Are those the same? Negative x plus 3 and 3 minus x? Yes. Right? Adding and subtracting doesn't matter the order, so negative x plus 3 would be the same as 3 minus x. So algebraically, we can say they are inverses. Now, graphically, we've already graphed the parabola part. The question is, if you were asked to graph, and I'll do it in green, if you were asked to graph this, first of all, it's complicated the way that it's written. We always write translations after reflections. So if you had this, I would suggest changing it to this. Then we have a horizontal reflection and a horizontal translation. This is not 3 to the left. Why? Because it's not in factored form. So we would have to first write it in factored form because we have a horizontal reflection and a horizontal translation. Whenever you have two horizontal things, it always has to be written in factored form. Now that it's written in factored form, if I was to graph this, can you see that this would be a square root graph with a horizontal reflection? So that would flip it over the y-axis, and then translated 3 units to the right. Which would look like this. That's how you would graph that function. Tricky because it has that factored form in it. Also tricky because of how it was originally written as 3 minus x. So you have to sort of rearrange it to how we're used to graphing these so that we're able to figure that out. Questions for practice on this one? 7, 8, 11, and 13. And 11 and 13 I would call problem-solving questions. So when you're working on those, if you get stuck, do not feel bad. Come in for extra help. But they will be a little bit more challenging.